AP Chemistry, Unit 4.9, Oxidation-Reduction, Redox Reactions. So we have two ways of memorizing which thing is which. We have Leo the lion says grr, or oil rig. Leo the lion, the Leo part means losing electrons oxidation, and the grr part, spelled G-E-R, is gaining electrons reduction. Or you have oil rig. Oil, the O in oil is oxidation, I is, and then L is losing. So oxidation is losing for oil, and then rig is going to be reduction is gaining. Pick whichever is going to be easiest for you to remember which direction is which. The main principle for redox reaction states that if one reactant loses electron, another reactant must gain them. And so we have a standard redox method for balancing out where those electrons are going. First, you need to go ahead and assign oxidation numbers to identify which element is either oxidized or reduced. So for this example here, I have solid aluminum reacting with an aqueous zinc compound, producing an aqueous aluminum compound and a solid zinc. Since aluminum and zinc are, when they're by themselves and not aqueous, when they're solids, are going to have their oxidative states be 0. And then when they are monatomic ions, their oxidative state is just their charge. I can see what charge is which. And so I can see that zinc is reduced and aluminum is oxidized. I am then going to separate the reaction into half reactions. And so my oxidation reaction is going to be aluminum going from having all of its electrons to having lost 3 electrons. And my reduction reaction is going to be the zinc ion gaining those electrons and going to a solid product. I am then going to balance the atoms utilizing coefficients and the charges utilizing electrons. I will then multiply the entire half reactions to make sure that the number of electrons lost in my oxidation is the same to the amount gained in my reduction reaction. So for the aluminum, to balance out the charge so that the charges are the same on both sides, I needed to add 3 electrons. And to make the charges the same on both sides being 0, for zinc I needed to add 2 electrons on the reactant side. Now these two don't balance out. This is 2 electrons, this is 3 electrons, so I need to go ahead and multiply both half reactions in order to make the number of electrons gained and lost the same. So I need to multiply my aluminum set by 2 and my zinc set by 3 in order for me to have 6 electrons on the reactant side and on the product side. I am then going to go ahead and add the coefficients back into the reaction if necessary. If there weren't any coefficients necessary, I won't add them. And I am not going to change the coefficients in their original half reactions. So I go ahead and collapse this down. I will have 2 aluminums and 3 zinc ions going to 2 aluminum ions and 3 zincs. And I can go ahead and do this for another problem here. So here we have solid chromium reacting with the aqueous iron 2 ion, forming chromium 3 ion and solid iron. I'm going to go ahead and assign the appropriate oxidative states for each. I will then go ahead and balance out the charges utilizing electrons. So I needed a grand total of 3 electrons on the product side to make the charges for chromium 0 on both sides of the reaction. And I needed 2 electrons on the reactant side to make my total charge for iron be 0 on both sides of the reaction. I need a grand total of 2 of this oxidative set and 3 of this reductive set in order to make 6 electrons appear on the left-hand side and on the right-hand side. They are then going to cancel as I collapse down, and my final balanced redox reaction is going to be 2 chromiums reacting with 3 iron 2s, producing 2 chromium 3s and 3 solid irons.